My name is R. Crosby Lyles, and this is News from Can. I've been out of commission for a while because of hardware and software failures of all kinds, and hopefully I finally got a lot of that stuff straightened out, and we're back to talk about this video that I put up a couple of years ago, and why and what does it mean and what's going on now. First of all, a little shout out to Paul Beckwith. He's a global warming guy. That's his thing. But I want to thank him for turning me on to the Copernicus instrument, which is right here, because this is a fabulous instrument. I mean, it's just really, it's really a terrific instrument for analyzing everything: aerosols, carbon dioxide, carbon monoxide, formaldehyde, methane forecasts, nitrogen dioxide, ozone, particulate matter, sulfur dioxide, UV index. Because bear in mind, the Earth's atmosphere is essentially a giant photochemical reactor. So this is the change during the day. The levels of nitrogen dioxide go up and they go down because there are all these intermediate species. For example, if you had a jar of air, if you sealed a jar of air, clean jar with nothing in it, like a mason jar with just a metal lid, and you sealed it, put it out in the sun, you could wait for 1,000,000 years and you would never see any ozone inside that jar. Spritz a little bit of methane in there and you're going to have some ozone. This is because methane is a reaction body. It's a buffer. It allows the ozone to keep from devolving into oxygen, diatomic oxygen. And, you know, our atmosphere is a mixture of different gases that are constantly reacting with each other and producing different species. That's important to remember, especially in terms of global warming, because the presence of ozone indicates the presence of methane, and ozone reacts with methane to produce carbon dioxide and water. The question is, how do you get to a rapid onset ice age from a heat wave? Here it is.
And the nearer surface layers.
How are these changes in the Arctic affecting the planet overall?
That's another very good question. So what I said earlier is we have the Arctic acting as a potential bellwether for climate change that might be going on elsewhere in the world. Large changes are being observed in the extent of sea ice over the Arctic Ocean. It's actually melting back much more as we progress into the future, and there might in fact be, in the next decade or two, a situation where we have ice-free Arctic Ocean in the summer, as opposed to an Arctic that has previously been covered by ice year-round. This freeing up of more open water area for longer periods of time during the summer is increasing the amount of water that is driven into the atmosphere from evaporation in the Arctic, and that's having large impacts in precipitation, either as rain or snow, in not only the Arctic, but into the lower latitudes as well. And it's thought that these combined changes in the length of the growing season, the amount of ice and the amount of water vapor, are actually making changes in the patterns of the jet stream, so that the recent periods of intense cold and snow, for instance, that have been experienced in the eastern portion of the United States and Canada over the last several years, are thought to be driven by changes that are actually taking place in the Arctic.
This is a theory that from the 50s, how ice ages are formed, and essentially their premise is that, this is from the 50s, that melting sea ice in the Arctic allows for more water vapor, which is the thrust of my video, the Armageddon Line, essentially, and that water vapor in the atmosphere produces the instability and massive amounts of frozen precipitation. It's basically reglaciates the landscape because of the lower heat capacity of the land versus the seawater. Yeah, there you go. That's new and different. Wow. That's sort of classic, drawing that moisture right up into a cyclone, just pulling it out of two streams, it looks like. pulling that moisture right up into Canada. So, what does reglaciation look like, and how extreme and how sudden is it? Are we going to have a super warm summer and then boom in the, in the fall? It's anybody's guess, but basically the boom is what I'm telling people to be prepared for. The poetic sort of thing about this, if you have any doubts about global warming, just know this. The Russians just can't wait, are waiting on bated breath for the global warming to come, because they actually make money on global warming. They've got all these hydrocarbon deposits off the coast of Siberia up here, and when it warms up even a little bit, you see women, good-looking women out like swimming in the gutter in the streets. Fascinating stuff. I mean, these people will strip their clothes off and go swimming in some unbelievable things, I mean, and it's just because they're indoors so much, and so anytime there's a break in the weather, they're ecstatic about the concept of global warming. So if you don't believe that there's such a thing as global warming, well, ask the Russians, and they'll probably tell you, I don't know, it depends on how it serves their interests. But pretty much but what any individual gets in any particular part of the planet depends on the angle of incidence of the sun, cloud conditions, and all of these things. It depends on what latitude you're at. The southern hemisphere right below the equator, that could be a real hell zone for as far as storms and things like that. It looks like they get hammered a lot anyway. Areas below the equator between the Indian Ocean and the South Pacific, they get 24 storms a year. Significant, serious cyclonic storms. Last year was a banner year for the Western Pacific. Taiwan and the Philippines and China, various parts of China and Japan, just getting hammered with serious cyclones. I don't know what the answer is, but it's certainly not burning more coal if we can avoid that. What are you going to do? The windmills kill birds. Solar's great unless you live, in somewhere where it's dark a lot. Then all of a sudden the solar ain't so hot. So you got to do something. And natural gas is probably a pretty good alternative for generating power and all that kind of stuff. I mean, it's just kind of sort of, to me, it just seems like the answer. It doesn't have the sulfur dioxide in it. It doesn't have the SO2 and the hydrogen sulfide and all that stuff wafting off of it when you burn it, So it just, I don't know. It's a better alternative. To me, a lot of the narrative that I see on YouTube and around the internet and stuff like that, it's sort of like chatting up the features, advantages, and benefits of coal, and coal's the worst goddamn shit you could possibly burn in the universe. I found out about the Copernicus Satellite System from Paul Beckwith, and it's a fabulous instrument for being able to see actually what's going on with different gases emanating from the Earth. So this is the methane forecast, and I just want to show you this. I'm going to play this for a second. He has actually done this on his channel, but I'm going to look at something a little bit different. You can see how it sort of moves around, but that the methane is persistent in Siberia and in Europe too. That's interesting. I'm not really sure. That might be coming from agriculture. Certainly is coming from agriculture. For a long time, most of the methane that's been produced that comes from the earth comes from rice fields in India and China. You can see how much methane's coming off from the surface level. Now, when you step up, I'm just going to go to 500 hectopascals, which is between 15,000 and 18,000 feet elevation. Most of that methane ends up more towards the polar regions. And when you get to the stratosphere, okay, here's 300 hectopascals, which is about 20,000 feet. Not so much. You get these little holes here. But here's the punchline. You get to the stratosphere, 50 hectopascals, which is between 50 and 60,000 feet, and you got this big giant hole here. An area that's devoid of methane. And this is something that I've put forth before, and it's a good time to reiterate it. This is, how you get a sudden onset ice age from a spike in global warming. Well, you get these pingos of feedback with underground pingos that start giving off a lot of methane, and you saw the persistent methane release from the ground level, from the surface level. And as you went up, there was more and more methane, and it sort of peaked out about 500 hectopascals, which is about 18,000 feet. A little bit further up, not so much. And then all of a sudden you got holes. Well, there's a reason for this. If you take a jar full of air, just oxygen and nitrogen, just regular, room temperature air, put it in a mason jar, that's a clean mason jar, and put it out in the sun, you can wait for 1,000,000 years and you're not going to see any ozone in there. You could take that jar out into space, just about, and you're not going to observe any ozone in that jar. Spritz a little bit of methane in there, and before you know it, bada boom, ching bang, you got ozone, because methane is a reaction body. And methane, volatile organic compounds, just the nature of the way they are in a photochemical reaction, they actually facilitate or catalyze a photochemical reaction that produces methane. So it's called a reaction body, methane. So methane has this funny little thing that it does where it produces, where it facilitates the production of ozone, and then ozone turns around and reacts with the methane to produce water vapor and carbon dioxide. Ozone. This is at the surface level, and I won't bore you with going, well, we can step through it, try to be as quick as we can. Your time is valuable. I don't want to waste it. Right? Kind of goes down a little bit. Get up to about 20,000 feet. You got some accumulations going on in these areas. All right. It starts, in other words, you start to see more ozone as you go up. And it's commonly thought that ozone is basically, it's a stratospheric phenomenon. So there you can see that there's not quite as much ozone right there. And it's completely devoid of methane. Carbon dioxide, the surface level. Let this play for a second and you can just watch the carbon dioxide going up and down. You see how low it gets. This is in the lower 300 parts per million. That blue. The red is above 418 parts per million. This is from plant respiration and photosynthesis. This over here, if you look at the carbon monoxide, you can see that, interestingly, carbon monoxide also waxes and wanes, and this is because, when people are asleep, they're not out in traffic producing carbon monoxide. Carbon monoxide is there are photochemical processes that produce carbon monoxide naturally. They do exist, but principally carbon monoxide is an anthropogenic substance that is put into the air. So you can see that here's carbon monoxide, and there's a lot of it wafting off of China. I mean, that's kind of absurd. It's just wafting right off of there. That's amazing. So that's at the surface level. Oh, I'm sorry. That's the total column. So you can see the smoking gun there with that, and this is at the surface level. So that shows you that carbon there is definitely emanating from people. Get up to the stratosphere, and the carbon dioxide is basically all wrapped around the equator. Now, you can see this, not quite as much carbon dioxide here, but around the perimeter of the methane hole. There's a hole there. Ozone, see that? It's methane, or ozone rather, is kind of wrapped around that. Carbon dioxide, kind of a similar sort of, paints a picture. And so here's your methane. This is 50 hectopascals, which is about between 50 and 60,000 feet elevation over the equator. Where ozone is, methane is not. So this is 150-ish parts per billion of ozone around the equator. So your ozone sort of tends to linger around the poles, and there are probably other processes there. So here's your carbon dioxide around the equator. Not so much ozone, more methane. So it almost looks as though the carbon dioxide that is in the atmosphere is coming from methane. This is total column. And in the total column you can see the footprint here. You can see that it definitely looks like carbon dioxide's coming off of China for sure. And North America, it looks like it's wafting off. It definitely gives that impression in some of these other areas. So that total column kind of gives you that impression. Yeah, China's got some mad carbon dioxide coming off of there, but it's persistent, and that's the other thing too. This is, this satellite data. It's surprising to me. So there's actually more carbon dioxide, over 418 parts per million, essentially in the stratosphere over the equator. So this says that with Arctic regions having a methane hole, and with equatorial regions having methane in the upper atmosphere and carbon dioxide wrapping around the equator, this necessarily means that you can have advanced global warming around the equator at the same time that you're having massive cold events in the Arctic Circle. And this to me is a footprint right here. This is a smoking gun. This big asshole right here. This is a smoking gun behind the methane trigger theory, or the methane trigger hypothesis for rapid onset ice age. So maybe common as dirt. Maybe it happens all the time. I mean, this might just be part of life. But one of the things you can tell from these maps is that the northern hemisphere and the southern hemisphere are like apples and oranges in terms of the gas makeup and global warming potential and all that stuff. Global warming has the word has been demonized to the point that when anybody ever even hears the word, and I use it just out of habit, climate change, but it's greenhouse warming. It's a greenhouse gas effect. So, and what that effect is it's more complicated. It's not just some cut and dried thing. You can't just pigeonhole it into one thing or another. We do have a part to play. But again, and I'll just reiterate as I close that it seems that there's a lot of interest. Supposedly there's a large number of coal-fired power plants that are opening up, I guess because Australia's got some significant coal stocks that they're probably trying to sell to India and Asia, India and China, because it's cheap, cheap power. But here's the thing: coal is the worst shit in the world to burn. It's got the nastiest crap in the universe in it. Coal is, they use activated carbon. They give it to people who have been poisoned so that the activated carbon will pull the poison out. It just absorbs everything, and that's how coal is. Coal sucks all of the worst possible crap out of the soil. It's got thallium in it, and mercury, and cadmium, and nickel, and all kinds of heavy metals, and just the worst arsenic and the worst crap in the world. And you're going to take that and burn it and put all that crap in the atmosphere. It just makes no sense. There is no such thing as clean coal. It's crap. We really don't need to burn it anyway because there's plenty of methane. You can burn natural gas just as easily. So, you know, it's the Doomsday warming scenario, the PETM, and I've said this before, the Great Dying, those were caused because of vast quantities of hydrogen sulfide and sulfur dioxide getting into the ocean, creating sulfuric acid, which has a very low, it says pH of 0. So it just, you know, acidifying the oceans. How you get to doomsday warming is by basically killing the plant life and killing the plant life in the oceans. Killing off the plankton, lowering the pH of the oceans to the point that they can't hold on to the CO2 anymore. That's when you get doomsday warming, because then you have persistent. If you just look at this for a second, what is this? Okay, let's go to carbon dioxide, surface level. You can see over the oceans. It's very low. It's what do they got? 398, something like that. So it's not totally without carbon dioxide, but it's lower. And if the oceans were acidified, then you would see a buildup of carbon dioxide at the surface level right over the oceans. And that's when you got a problem, Houston. So, by all, that's the message, is that these guys want to sell coal. These PR people, they want to make everybody believe that global warming is not a thing, and they're getting ready to open a whole bunch of coal-fired power plants so they can sell that cheap coal from Australia and other places. You know what I mean? And God forbid they should deregulate, or they should burn that coal without taking out without getting that, that hydrogen sulfide out of there, without getting that sulfur dioxide out of there. And you're going to have the acidification of lakes and streams and landscape. And in the 80s, half of all the sulfur that was released into the atmosphere was released by human beings. More so than volcanoes and anything else. And that's quite a feat. Here's your sulfur dioxide forecast. Surface level, total column. I'll just look at the total column. Sulfur dioxide. Wow. Yeah, I think there's a volcano down here. Yeah, that's a lot of sulfur dioxide coming off of China. Yeah, so that's, they've got that industrial thing going on, and so that's the planet killer. Sulfur emissions. The PETM and the Great Dying and all that stuff, the Permian Triassic, that was all caused from massive amounts of hydrogen sulfide, sulfur dioxide hitting the ocean, bottom line. So the carbon dioxide alone is not going to be enough to do us in, You have to do something to the ocean. You have to damage the ocean to the point where it can't absorb that carbon dioxide. Obviously. And that's all I got. My name is R. Crosby Lyles. You can see the cold weather out there. It's going down. So how much frozen precipitation that translates into remains to be seen, but we have seen cataclysmic snowfall in the Alps and a lot of areas around Austria and Germany, and even in parts of the United States. So we've seen some pretty significant snowfalls. What we've seen in the United States is not what I would necessarily term that's tame compared to what I'm thinking we might experience. Now Canada, that's a different story. because that's where your glaciation is going to begin. You know, if you're living in Canada, I say above the 40th parallel, be prepared for it's amounts of snowfall that no human being has ever seen before. Tens of feet of snow, continent wide, that type of stuff. I'm not necessarily seeing that materialize yet, but they've had some snowmageddon type of events, 10 feet or more of snow falling in Europe, different parts of Europe. As a matter of fact, they got some snow going on right now. So yeah, let's look at this thing here. Wow, So these persistent weather patterns, they set up and start dumping snow. So anyway, that's all I got. My name is R. Crosby Lyles. Y'all be safe out there. Be prepared. Stay provisioned, and ain't no telling what's going to happen next. But stay warm. My hearts and prayers are with you. My thoughts and prayers are with you cats out there that are freezing your butts off up above the 40th parallel. And that's it. My name is R. Crosby Lyles. Thanks for watching. See ya.